In this video, we will present how to use ParaView for advanced model rendering for optimal results, Plaxis result presentation with a special emphasis on advanced selection. We do have here a Plaxis model representing an high wall on a levee with the following constitutive element: the foundation wall, the sheet pile wall here, and batted pile with H profile beam. The first thing we will do is use the extract mesh entity to create sources for each of the structural elements and for the soil right here. The first thing we will do is focus on the plate elements, which are being used here to model the sheet pile wall and the H profile beam, and create two groups, one for the sheet pile wall and one for the piles. So this will be done this way. We will use here the option select cells through and then draw a rectangle containing the sheet pile wall elements, and then use the extract selection and give this new source a proper name. We will repeat the operation with the remaining element, and we will this way create two groups. So one for the right piles and another one for the left piles, using still the select cells through. And then click on extract selection, L pile. So now that this is being done, we have managed to identify independently the sheet pile wall and the pile in separate sources. We will do the same for the L foundation, which has been modeled using continuum elements. So we will take a look at the soil element here and maybe use some opacity lower than 1 to be able to see through and guess the shape of the foundation. So now the idea is to create a group just for this particular part here. Using sometimes the selection tool from ParaView might not be the most handiest way to create the selection. Another interesting one here is to make use of the mesh entity name, which is always provided in the ParaView files generated by Plaxis. So this can be done by creating a new view, a spreadsheet view, and taking a look at the cell data. And this is where the mesh entity name. And what you see now, the mesh entity name contains or subdivides the entire model into subsets, all given the same mesh entity name resulting from the Plaxis clustering operation. So to create the first group, which corresponds to the wall, we will select all the elements that belongs to mesh entity 1 and 4. This way, you see, so now all those elements are being selected, and now could be extracted into a separate source. We will call them wall. And we will do the same for the foundation. So the foundation elements we could look corresponds to mesh entity 7 in this particular case. So you see, so we will select all the elements with the mesh entity 7 this way. And then once more, extract selection. That will create what I will call raft here. So I can now close the spreadsheet view, get back, and now you could see I have the wall and the raft. So now what I will do, I will demonstrate the use of a new functionality in ParaView, which consists of grouping independent datasets. So I will just select all the sources corresponding to the structures in my model, and I will use the group dataset functionality, which will lead to the creation of a new group, and each of the subgroups will be given a different block number. And based on this block, we can manage the colors of the entities. So here I think we are quite fine with this one. I will change the white one into maybe another color, might be more like a dark blue. Yeah, that's it. So now that this has been done, we could rename this source like structures, and then start superimposing different sources to offer an interesting result rendering, like this one, for instance, where we are here superimposing the soil with the structure. And for even better representation, we could apply an additional feature to both sources, soil and structures, by warping by the displacement vector. So here I will select the displacement with a factor 10, for instance, and use for this one solid color with some opacity less than 1, and apply the same filter, warp by vector, to the previously created structure source, and apply the same scale factor as before, 10. So this provides the final results view I wanted to show. Eventually, we could use for the soil surface with edges, with maybe some different color for the edge, something slightly lighter, and see the representation that finally could be animated by clicking on the play button here. And this way you could generate an animation of what's happening when the load will be loaded, when the wall will be loaded.